Paolo is the director of the Florence Science Museum, which is an exemplary science museum that shows us what the joining of an outstanding physical collection of artifacts with imaginative and digital media can do. It's a museum that, despite all the financial woes that have afflicted Italy of late, has managed to keep a standard of exhibition and scholarship at the absolute highest level, and been involved with the preservation of historical documents and artifacts in a myriad of ways. So it's with great pleasure that I welcome Paolo Galluzzi to our conference today.
It is well known that Federico Cesi has been evoked a few times. Federico Cesi this morning, the Roman patrician who founded in 1603 at the age of 18 the Accademia dei Lincei, generally translated in English as the Academy of Lynxes. I don't know why, because it's wrong. It should be the Academy of the Lynx-eyed, not the Lynxes. Cesi played an important role in the process that led to the publication of the letters on sunspots. The Roman prince generously paid the costs of printing, which were remarkably steep due to the numerous copper engravings. You have seen many of these this morning, and to the print run, which was extremely high for the era, slightly less than 2,000 copies. Cesi made every effort, unsuccessfully however, to avoid having the work mutilated by censors who did not approve the passages in which Galileo sustained the Holy Scripture confirmed the corruptible nature of the heavens. The image of Cesi that emerges when examining his active participation in the publication of the Letter of Sunspots is that of a convinced supporter of Galileo's ideas, an ally in this battle to affirm a new vision of nature. This is a blurry image, however, which does not allow us to grasp just how the prince experienced this extraordinary season of discoveries, nor to understand the impact that the sensational novelty of the spotted sun had on the project that he had conceived before having even heard of Galileo. In actual fact, the vision which at a very early age had motivated Cesi to establish the Academy of the Lincei appears quite distant from Galileo's conception of nature. Anyone who dwells on the orientation and expectations of the Academy between 1603, when it was founded, and 1610-11, when the prince had first the opportunity to look through the lenses of a telescope, then to read the Desiderius Nuncius, and lastly, to meet Galileo in Rome, cannot help but be struck by the differences in his perspectives with respect to Galileo's priorities and research agenda. One needs simply to examine the points of reference of Cesi and his companions, the Renaissance philosophy of nature, astrology, natural magic, chemical philosophy, and the conception of a nature pervaded by vital principles. There is no need to underline the gap between those horizons and Galileo's immersion in studies of mathematics and mechanics, inspired by the divine works of Archimedes, as well as of cosmology, with the precocious manifestation of his clear inclination towards the Copernican vision. In the long tradition of studies on the Roman Academy, often fueled by celebratory aims, the embarrassing beginnings of the institution have systematically been concealed, or at least minimized. This has made it possible to exalt the Galilean spirit of the Lincei Fellows, thus corroborating the image of the Academy as the first scientific society of the modern era. The interpretation of this conversion to the new science after Galileo's association has enjoyed widespread and long-lasting fortune. Only recently, scholars have begun to acknowledge that the encounter with the Tuscan scientist did not induce Cesi to set aside the motivations and aims conceived when the institution was established. The interpretation of the Galilean refoundation of the Academy in 1611, after a false start in 1603, explains why we still do not have an intellectual biography of Prince Cesi. That is, a study focusing on the ambitious project he had conceived to reform traditional knowledge and the results that he achieved. I will try to outline the way in which Cesi assimilated the celestial discoveries announced by Galileo. In particular, I will focus on the impact that the discovery of sunspots and Galileo's interpretation of them had on the Prince's research agenda. Cesi's frequent contacts with Galileo in Rome in the spring of 1611 convinced him that the celestial novelties made it necessary to update the Academy's programs. But the prince had no intention of abandoning or overturning the vision that had inspired its beginnings. During the months in which Galileo was writing his letter on sunspots, Cesi reset the original agenda of the Lincei with the aim of making space in it for Galileo's novelties. The first clear evidence of this operation emerged in the letters on sunspots. Repainting the Academy's original image with Galilean colors was an extremely delicate operation. It implied generating the impression that the interests, orientations, and vision of nature of Giovan Battista della Porta, the undisputed inspirer of the Academy from its foundation, moved in the same direction as the discoveries of Galileo and complemented them. Other factors made the operation even more delicate. Della Porta himself was not at all pleased with the success that Galileo had reaped thanks to the telescope, which he claimed as his own invention. In turn, Galileo had no sympathy for the obscure research paths of the author of the Magia Naturalis. For an idea of the image of the Della Porta that circulated in Galilean milieu, we need merely read what Giovan Battista Sagredo, has been evoked many times this morning, the Venetian friend of Galileo, had to say about the Neapolitan. Quote, "I think Della Porta's place among scholars is like that of church bells among musical instruments." End of quote. Galileo's letter to Cesi of May 12, 1612, helps detect the strategy conceived by the prince to stress the convergence between the perspective pursued by the Academy's original agenda and the Tuscan scientists' research priorities. In this letter, Galileo informed the Roman prince of the conclusion he had reached regarding the nature of sunspots. This new discovery excited Galileo above all because of its Copernican implications. Nevertheless, in his letter, he did not dwell on this aspect, stressing instead the definitive proof that the spotted sun provided of the fluid and corruptible nature of the heavens. He was aware that while hesitating to embrace the Copernican vision, the prince was a stout advocate of the penetrability and corruptibility of the skies. Furthermore, he knew that Cesi, even before leafing through the pages of the Desiderius Nuncius, had made those principles the cornerstones of his general vision of nature and of his project for the radical reform of knowledge. He had reached these conclusions based on his reading of the works of Telesio, Persio, Patrizzi, Tycho Brahe, and even of Giordano Bruno. The message Galileo sent to the prince had the tone of a prophetic annunciation of the imminent collapse of the traditional concepts of the solidity and incorruptibility of the celestial bodies and skies. I'm quoting in English that statement. I believe this discovery will be the funeral, or perhaps the last rites, of the pseudo-philosophy, because there have already been signs in the moon, the stars, and the sun. I hope that the montuosity of the moon is about to turn into a joke or a minor irritation compared to the scourge of the clouds, smoke, and vapors that are produced, moved, and dissolved continuously on the very face of the sun. End of quote. Cesi answered enthusiastically, begging Galileo to send him the text on sunspots as soon as possible. He was determined to release it as an official publication of the Academy. A few weeks later, Cesi informed Galileo of reflections that the discovery of sunspots, and above all the Tuscan scientist's interpretation of that phenomena, had sparkled in him. Despite Galileo's pressure during their encounters in Rome in 1611, Cesi still hesitated to embrace the word system of the author of De Revolutionibus. He found it difficult to accept the jumble of orbits, epicycles, and eccentrics of that system. He could not envision the creator devising such an intricate, disproportionate, and inelegant structure. What held him back above all, however, was his suspicion that Copernicus maintained the solid spheres, thereby accepting the traditional division of the universe into two distinct zones. Cesi wondered how Galileo could justify his explicit affirmation in the letters on sunspots of the fluid and corruptible nature of the heavens, while accepting a world system in which the planets fastened within crystal spheres described highly intricate trajectories. Without hesitating to impose his own thoughts on those of Copernicus, Galileo promptly replied that, according to the Polish astronomer, the planets move freely through the fluid celestial space, traveling with absolute regularity and a constant speed along the orbits assigned to them by God. Whether those paths appeared either elegant or disproportionate to us was of no importance, given that the methods employed by nature do not take our concepts of elegance, proportion, and beauty into any consideration. If we admit, replied Cesi, that the planets cross the fluid spaces of the heavens guided by an internal principle of motion, a spirit masterfully programmed by the Creator, then there would no longer be any difficulty in accepting the existence of paths along epicycles, eccentrics, or any other trajectory. But, he remarked, if we dispose of the solid orbs, would it not make more sense to accept the elliptical orbs described by the planets in the fluid heavens proposed by Kepler? The letters that he exchanged with Cesi in 1612 demonstrate that the prince's acceptance of this or that word system was bound to explicit acknowledgement of the fundamental principles of the fluid and corruptible nature of the skies. His suspicion, however, that the assurances of Galileo regarding Copernicus' position on this point were instrumental prevented him from accepting the Copernican vision. It is not surprising that in his correspondence with Galileo during the long phase of preparation of the letters of sunspots, the prince systematically avoided commenting on the transparent Copernican implications of Galileo's interpretation of sunspots. He did not recognize in this the most relevant aspect of the work. It was above all in the demonstration of the fluid and corruptible nature of the heavens that Galileo felt perfectly attuned to Galileo. Another document helps reconstruct the workings of the prince's mind in the face of the celestial discoveries and above all of Galileo's interpretation of sunspots. Unlike the correspondence with Galileo on cosmological questions of 1612, which has attracted the attention of scholars, this document has been overlooked. Yet, Cesi drafted it during the same months in which he was receiving constant updates from Galileo regarding the progress of his works on sunspots. Cesi conceived this text with the intention of demonstrating the convergence between the aims of the Academy's original agenda and Galileo's interpretation of the most recent of his celestial discoveries. As the title indicates, is a Latin title, outline of the philosophical works that Prince Cesi plans to compile. This document presents a detailed scheme of the ambitious research program elaborated by Cesi with the aim of radically reforming knowledge about nature and man. We are not surprised that the fundamental principle of this program was the unity, fluidity, and corruptibility of the heavens. In his opening remarks, Cesi outlined the vision that had inspired him, designing a new theater of nature, a universal encyclopedia articulated in several sections, all closely connected with each other. He defined those sections frontispieces, a term that instinctively called to mind the image of a book. His theater of nature, this was the message, was the mirror image of Galileo's book of nature. The frontispieces that opened his theater of nature was entitled Physico-Mathesis. Here, Cesi envisioned an orderly classification of all aspects of nature that man can bring into focus through physical and mathematical investigations. In actual fact, this frontispiece presents an extensive enumeration of principles and concepts from which it is impossible to glean signs of any intent to conduct a quantitative analysis of natural phenomena. More than the influence of Galileo's lessons, we perceive in the Physica-Mathesis the presence of the themes and motives of the Renaissance philosophy of nature, evoked even in the terms used to indicate the causes of the interactions among natural substances, hostility, friendship, sympathy, and so on. Equally evident appears echoes of the Paracelsian tradition and of chemical philosophy. The Physico-Mathesis was immediately followed by a new frontispiece in which Cesi presented the research that he intended to devote to celestial questions. He gave this section of his theater of nature the title of Celispiccio, meaning observatory of the sky. While with the opening statement, Cesi underscored the continuity between the frontispiece of the Physica-Mathesis and that of the Celispiccio. The cosmos is unitary. The skies are governed by the same principle as the subunary world. Nature is organized like a great and finally graduated chain of being, along which all creatures and entities flow without interruption. The scheme of the Celispiccio reveals the prince's plan to identify the effective nature and substance of the sky, the natural sky as he calls it, contrasting it with the absurdly intricate and unnatural one posited by traditional cosmology. After listing the bodies and elements present in the sky, stars, ether, air, heat, fire, light, and so on, Cesi sketched out the new image of the universe that would emerge from his reform of traditional conception. The sky would appear unitary, penetrable as air, immobile, and crossed by bodies freely moving through it. At this point, Cesi offered an enlightening clarification. He did not strive to design a new world system. He intended instead to focus attention on the problem of the material structure of the heavens. In his opinion, only after successfully overcoming this challenge would it become possible to tackle the crucial question of the real structure of the universe. Like Galileo, Cesi wanted to base the new cosmology on demolishing the paralogism of the old, but the task he had assigned to the Celispiccio did not coincide with the Tuscan scientist's agenda. Cesi remained a step behind. Before advancing an exhaustive interpretation of the movements of the planets, of their reciprocal positions, and above all, of which body occupies the central position, several quick questions had to be answered. What is the sky made of? It is fluid or solid? What are fire and light, and how are the two to be distinguished from each other? What is the nature of comets and novae? And finally, what can we learn from the recently discovered sunspots? In the sequence of the frontispieces of the theater, Cesi had assigned a strategic position to the Celispiccio. As I said, it followed immediately the Physico-Matesis and preceded the Taumatombria, that is, the treatise on the marvelous celestial reigns, in which treatise intended analyzing the substances that fall to earth from the sky. The reader instinctively perceives a radical change in scenario, but it is a deceptive impression. Cesi emphasized that there was no solution of continuity between the two frontispieces, that is the Celispiccio and the Taumatombria. This is confirmed by the fact that the Celispiccio ended with an affirmation of the existence of a force resident in all bodies, while at the opening of the Taumatombria, emphasis was put on the marvelous forces inherent in nature. In the Taumatombria, Cesi strived to examine the questions discussed by Aristotle in his treatise on meteorological questions, which the Greek philosopher had considered a field of research separate from studies of celestial motions and the nature of the heavens. For Cesi, that clear-cut separation was arbitrary. The continuity between the sky of the earth and the celestial spaces, as well as their homogeneous nature, were demonstrated by the substances emanated by the earth, fumes, exhalations, vapors, that ascended to the most remote regions of the heavens. Once condensated by the cold temperature of the sky, this substance fell again to earth in the form of a variety of rains that nourished animals and plants and fertilized the soil. Thanks to this marvelous rain, the purest of products, extremely beneficial for man, such as dew, manna, and with the fundamental collaboration of bees, honey, were generated. According to Cesi, nature had to be conceived as a long chain along which one could descend from the noblest celestial contemplation to the most minute phenomena unfolding on earth, passing seamlessly through every intermediate link. We see now more clearly the chain of reasoning that Cesi followed in organizing his project for a new encyclopedia of nature on nature and man. From an abstract reflection on the perfect correspondence between the categories of reason and the architecture of nature, to a hierarchical and relational classification of the physics of the elements. From there, he proceeded to analyze the celestial phenomena to arrive uninterruptedly at investigating atmospheric phenomena and also those that occur not only above the Earth's surface, but also below it. We are now in a position to understand the impact that the sensational discovery of sunspots and Galileo's interpretation of that phenomenon had on the research program that Cesi had conceived 10 years before. To use his own words, the continuous communication between sky and earth, end of quote, and the corruptible nature of the sky appeared to him to be the principles on which to base his claim that the Academy's project for the radical reform of natural philosophy and Galileo's innovative research complemented each other. The Tuscan scientist was revealing the true nature of celestial bodies and spaces, while the fellows of the Academy, spearheaded by their prince, were committed to the equally important and perfectly symmetrical task of reforming the traditional interpretation of phenomena observed above and below the surface of our planet. The direct connection between the Taumatombria and the Celispiccio also made it possible to present the vision of Giovan Battista della Porta, who had first inspired the program of the Academy, and the agenda of his new mentor, Galileo, as being substantially convergent and complementary. The natural magician from Naples had written a treatise, a Taumatologia, that is, a treatise on the marvelous operation of nature, that the very title of which clearly shows that it served as a model for drafting Cesi's Taumatombria. The Prince of the Lincei, suggested that while developed independently, the innovative contributions of the Academy's two most prestigious fellows converge in the objective of the general reform of natural philosophy. The message that Cesi intended to transmit is clear. Galileo's abrupt arrival on the scene, while conferring new energy to it, did not compel the Academy to abandon its original program. Cesi would never have settled for the indulgent interpretation that would later on be developed of the Galilean conversion of the Academy after 1611. He urged a far more ambitious objective, demonstrating that the design originally conceived by the Academy and its prince and Galileo's discoveries and research methods contributed with equal dignity and effectiveness to the radical reform of knowledge. This lucid operation was presented to the public for the first time in Galileo's letters to SUNSPOTS. Cesi considered this text of vital importance not only because of its content, but also because it was the Academy's first official publication, a decade after it had been founded. The prefatory letter by the Academy's fellow, Angelo De Fili's, explicitly emphasized the complementary and convergent character of the Academy's aims and Galileo's celestial discovery. I quote from the Italian text, translated in English. If we take such delight in and praise their discoveries so much when investigators of that lower realm of nature that lies under our feet reveal the birth of something never before seen, be it an animal, a plant, or a deformed zoophyte, how much should we not rejoice when we are presented with new lights in that bigger realm of the highest heaven, and the faces of the noble discoveries once veiled and are now revealed to us? This is a very eloquent text of the operation Cesi has in mind, to make a symmetric work between Cesi, who is working on the Meteorologica by Aristotle and working on the surface, and Galileo, that is exploring the sky. Thus, that's the conclusion, the heralds of the celestial novelties and the heroic minds of the discoverer of the zoophytes, zoophyte was the pet project of Prince Federico, who passionately devoted to studying this ambiguous nature, midway between plants and animals, deserved equal merit. That was the goal of this operation. 10 years later, in the Mexican Thesaurus, the most ambitious initiative of the Roman Academy, the German Lincei fellow Johann Faber would place even greater emphasis on the convergent character of the contribution of Cesi and Della Porta on the one hand, and that of Galileo on the other. The Academy and Galileo had joined forces to reform both Aristotle Meteorologica, the duty of the Lincei fellows, and the Cielo, the task of Galileo. A totally new vision of nature and the ways in which it operates would emerge from this coordinated division of labor. This ambiguous interpretation would later be reproposed by another fellow of the Academy, Francesco Stelluti, in his commentary on the satires of Perseus Flaccus. To further emphasize the image of the Galilean Academy, Cesi conceived yet another strategy. The prince suggested that the telescope perfectly matched the spirit and the expectation of the Lincean program. Not by chance, in the writings of the lynx-eyed fellows, the new instrument was presented as the outcome of the joint efforts of Della Porta and Galileo. Moreover, Cesi underscored the fundamental role that he personally and the fellows of the Academy had played, not only in dubbing the new instrument telescope, but also in prophetically heralding its advent. This prophecy was implicit in the lynx, the feline with the most acute sight, symbol of the mission and identity of the Academy. Although in 1603 Cesi had adopted the feline under the influence of the Della Porta Magia Naturalis, he did not hesitate to suggest that the lynx had announced the epiphany of the telescope. Both the animal and the new instrument expressed the need to return to observe nature with more penetrating eyes. While Galileo's instrument made it possible to observe celestial phenomena invisible to the naked eye, the lynx's keen sight penetrated the interior of things, revealing the occult principles of the workings of nature. From 1612 until the Academy ceases its activity in 1630, Cesi and his fellows would use the impression Lincean telescope with relentless insistence, stressing that the instrument and the new objects it had unveiled emblematically expressed the spirit and aims of the Lincei. One of the Academy's four founders, the Dutch fellow Johann Heck, would go even further, celebrating Galileo for having given the lynx-size lenses that sharpened its size even more. Later on, the prince and his collaborators would manifest the same strategy of appropriation with the microscope. In his letter on sunspots, in the letters on sunspots, the lynx was evoked not only by the image of the crowned feline in the middle of the title page, and by the emphasis, you are familiar with this image, of course, and with the emphasis on the fact that the author of the work, the person to whom it was dedicated, and the man who had penned the foreword were all fellows of the Academy. Francesco Stelluti, Cesi's most trusted collaborator, evoked the image of the feline in his celebratory poem opening the letters on sunspots. In it, Galileo was praised for having discovered those spots scattered. Sorry, this is another one. This is the right one. In this poem, Galileo was praised for having discovered those spots scattered about the sun's bright mantle. Indeed, the expression spotted mantle instinctively calls to mind an animal skin, like the lynx spotted mantle, rather than the surface of the sun. This was one more a brilliant way of underlining that the lynx of the Academy had prophetically heralded the spotted sun. It is not coincidence that another of Cesi's closest collaborator would define the lynx as being born of light. Thank you. There is no formal reaction or signs of being embarrassed of that operation. And one of the most evident signs is that two poems in this Istoria, in these Sunspots letters.
Oh, could you speak to the microphone?
You're
so
right,
they can
yeah.
hear in the back?
Excuse me. There is one pretty evident, pretty good evidence. The poems were two. One is the one that I've quoted by Stelluti, the other one was from Faber. And Faber was defining the telescope as not as the legitimate son, but the adopted son of Galileo, just stressing that before him, Della Porta had played a very important role. And we have several evidence that Galileo didn't like that. He didn't like to be put together with Della Porta. And when the edition was published again a few weeks after the first one, and was republished, of course, for many reasons. One was that also there were mistakes. These two poems disappeared. and it's no evidence, direct evidence, but most probably Galileo said, please take those away.
Other thoughts? Yes, Nick.
I have a question on the vocabulary, especially changes of vocabulary. The term macchia or macula is used extensively in the Sidereus Nuncius. And it's always puzzled me that Galileo says there are ancient marks on the moon, and then there are the new ones which I've seen, like the big stains, and then what we think of as craters. And it seems there that he's not just using the term macula because it's the only term available, but that he's very actively trying to terrestrialize the moon. This is an ethical term as well. Now, in transferring that term over to the sun, well, I guess my question is, that would seem to fit in very nicely with Chase's insistence on the corruptibility of the heavens. But at the same time, in the Sunspot letters, Galileo turns around the implicit metaphysics of corruptibility and says, why do we think of change as corruption? Why can't we just think of it as change?
Sure.
So is that an implicit critique of Chase's notion of corruptibility?
Might be. There is, again, no evidence to support firmly this thesis, but it's certainly a different vision of corruptibility between Galileo and Chase. And corruptibility for Chase is instrumental to putting the sky in communication with the earth. All the rest of his work, the Apiarium and the Tabulae Philosophicae, are based on the idea that something is falling from the deep profundity of the sky and is interacting with the objects that are on Earth. So this, for him, is the basic. He's not so much interested in the world system. He will never become a Copernican, Chase. Never. He will not against. He will stay on the side of Galileo because the principle of the Academy was the defense of the freedom of philosophy. And so Galileo was free to defend Copernicus, but it will never become. His interest is in that. And obviously, there is another big difference that you perceive in the sunspots, and is the problem of anthropocentricity. Galileo is strongly anti-anthropocentric in the Istoria, and there's a beautiful statement towards the end of the work in which he says, I believe that these fixed ideas on incorruptibility of the sky is depending on the fact that man fear dying. and so they believe that if something is going to remain, might be the same to happen to him. On the contrary, Chase is strongly anthropocentric. And this is also the reason why he's looking more sympathy towards Kepler than to Copernicus and Galileo, because Kepler is anthropocentric, as Tycho was.
That's Stephen.
You mentioned at the beginning of your talk the problem of censorship, religious censorship, that Chase was sort of. And I wonder if you could just say a little bit more about it. I mean, for people coming from Zion, both with ignorance, but also from English literature, there's a famous passage, as you know, in Milton, in which Satan, the sun, is likened to the sunspot that the astronomer, meaning Galileo, has seen. And I'm curious as to what extent the shadow of religious reform and the anxieties generated around religious reform in Italy in the early 17th century is reflected in the anxiety about publishing any of this.
In fact, is the fight in 1613 with censors was about corruptibility, not fluidity. Fluidity was accepted. And also Cardinal Bellarmine was in favor of fluidity of the sky. But there was a very strong opposition towards corruptibility. And when the text was submitted to censors, and Chase was in charge of doing that because he was living in Rome, he felt immediately that they were ready to accept fluidity. They also were not so sensitive to the Copernican explicit vision inside the text, but they were rigid against corruptibility. And Galileo was compelled to cross pages. And also were very sensitive at the stage that Marcus Welzer has been evoked this morning many times, had in his letter to Galileo that were going to be published in front of the first letter on sunspots, had quoted a small text from the Bible from which you had the idea that the Bible was in favor of corruptibility of this. And he was compelled to remove this. And Welzer was very close to Jesuits, was a very traditional thinker, was not a revolutionary person, but he had to remove these. And I don't know if there is any influences, the one that you said, I have no evidence to give, but it's certainly possible what you suggest, and it might be nice to think about that.
Good. I will thank Paolo Galluzzi.